Hello friends, today we will start with new module that is dimensional analysis. We will start with the introduction. What is dimensional analysis? Dimensional analysis is a mathematical technique which makes use of study of the dimensions as an aid to the solution of the several engineering problems. Each physical phenomenon can be expressed by an equation or composed of variables. It has a physical quantities which may be dimensional and non-dimensional quantities. Dimensional analysis helps in determining the systematic arrangement of variables in the physical relationship and the combining the dimensional variables to form a non-dimensional parameters. In the study of fluid mechanics, the dimensional analysis has been found to be useful in both analytical as well as experimental investigations. Some of the uses of the dimensional analysis which are explained below. First one is testing the dimensional homogeneity of the any equation of the fluid motion. What is dimensional homogeneity? We will see later on. Deriving the equations expressed in terms of non-dimensional parameters to show the relative significance of each parameter. And third one is planning model test and presenting experimental results in a systematic manner in terms of non-dimensional parameters, thus making it possible to analyze the complex fluid flow phenomenon. In order to facilitate the study of dimensional analysis and its application to the practical problem, a preliminary discussion about the dimension is given below. What is dimensions? Temperature is a spatially useful in compressible fluid or compressible flow. All other quantities such as area is equal to meter into meter or foot into foot, volume, meter cube, velocity, meter per second, acceleration, force, energy, power, etc. This term as a derived quantities or a secondary quantities because they can be expressed in terms of the primary quantities. What is dimension? The various physical quantities used by the engineers and the scientists to describe the given phenomenon can be described by a set of quantities which are in a sense independent of each other. Which are these quantities? These quantities are known as a fundamental or primary quantities. The primary quantities are mass, length, time, and temperature. I will repeat this. The primary quantities are mass, length, time, and temperature. These are represented as letter M, L, T, and theta respectively. Capital M for mass, capital L for length, capital T for time, and theta for temperature. The expression for a derived quantity in terms of primary quantities is called as dimension of that physical quantity. We will see the example. The dimension of force can be expressed as indicated below. What is force? As we know that force is equal to mass into acceleration. Since acceleration, see the formula for the acceleration is meter per second square. This is the unit of the acceleration. We will represent in terms of length and time L and T, which is equal to L upon T square. This is our acceleration, and mass, which is denoted by capital M. As we know that force is equal to mass into acceleration, therefore our force is equal to mass capital M, and acceleration L upon T square, L upon T square. And our dimension is M L T raised to minus 2. Okay, this is the dimension of a force. The rectangular bracket signifies that the dimensions of the quantity are being considered. This is one is our rectangular bracket. MLT raised to minus 2 7. This is inserted in a rectangular bracket. That the dimensions of the quantity are being considered. Some engineers prefer to use the force instead of mass as a fundamental quantity because the former is easy to measure. The system is then represented by the symbol FLT instead of MLT. Only there is a change in a force and mass. The dimensional form of any quantity is independent of the system of the units, SI, metric or English, chosen and enables us to convert the units readily from one system of measurements to the other. There is a table. It gives the dimensions and units of the measurement for the various physical quantities which involved in the problems concerning the fluid flow. In this table, we have a four columns. First one is for quantities, symbols, dimensions. It has MLT or FLT. SI unit of the quantities, then unit of measurement. Okay, which in both metric as well as English. Our first is for geometry. That is general. For length, it is a linear measurement. It has only one quantity, that is length. It is represented by capital L in both MLT as well as FLT. Its SI unit is meter, which is denoted by small m. Metric, small m. In English, we will measure in feet. So, similarly for area A, formula dimension in MLT and FLT L square, SI unit is m square, metric unit is also m square, and English unit is feet square. Similarly, we have the different quantities, that is volume, curvature, slope, angle, shape factor, and our dimensions are in MLT and FLT. We have both for kinematic. Take screenshot of this. First one is geometric. Take screenshot of these quantities. Here, table 1 gives the dimensions and the units of the measurement for the various physical quantities which are involved in the problems concerning the fluid flow. What are these? We will see in the next slide. Here, there are the four columns. First one is quantities, symbol, dimensions, and their units of measurement. Here, dimensions in terms of MLT and FLT. Already we know that what is MLT and FLT. SI unit, metric unit, and English unit, which is in feet, feet square, feet cube, etc. First one we will see geometric. Length. It is a linear quantity or linear measurement. The symbol is L. MLT or FLT, both are L. SI unit and metric unit is M, and last one English is in FT, that is feet. Area, that is meter into meter. This is the area. Dimension is L square, both in MLT and FLT. SI unit M square, metric unit also M square, and English unit is FT square, that is feet square. These are the some geometric terms and their symbolic representation, dimensions and their units are given. Take a snapshot of this image. Also, we have kinematics. This time, velocity, angular velocity, their symbol, dimensions and unit measurements are given. In next slide, we have a dynamics, that is mass. Symbol is capital M or small m, and dimensions in MLT is capital M, and FLT is Ft square upon L square. SI unit is kg. Metric unit is metric slug, in bracket MSL. It is also called as MSL or gram mass. Similarly, English unit is slug or IB, in bracket mass. These are the some dynamics: mass, force, weight, density, specific weight, specific gravity, pressure, intensity, etc. Their symbols, dimension, units, and measurements are given. Here, shear stress, dynamic viscosity, surface tension. We should know their dimensions and units of measurement. Modulus of elasticity, compressibility, impulse, momentum, work energy, torque, etc. Power, weight, rate of flow, moment of force, moment of inertia of the area, moment of inertia of mass, etc. are given. Then, heat, these are the dimensions. There are some dimensional quantities: Reynolds number, Faraday number, Euler's number, Weber number, Mach number, friction factor, kinetic energy, correction factor, momentum correction factor, efficiency. These quantities don't have any dimension, and their dimensional quantity MLT and FLT both are zero. That is